Hello everybody, this is Mrs. Ellsworth. You might notice my southern twang I got going on. That's because I'm wishing for some southern warmer weather. And since I can't travel, I'm going to be southern today. Anyway, when we are looking at these objects like this, notice how it looks like a house or a shed? Anyway, do you notice that it's got a triangular base prism right here? That here is the base to it. And right here is a rectangular base prism on the bottom. So this isn't that bad, is it? So what we're going to do is we're going to add up the volume of the top and the bottom, put them together, bippity boppity boo, there you go. So, question is, what is the area of this base? It does have a bottom right here. I can't keep this on, I'm just going to have to go normal. Anyway, it's got a base of the triangular base, right, of 13 inches. What is the length of this triangular base prism? Well, got 6 inches, so that's where that comes from. Okay, so you guys can solve that one. Let's look at another one. This kind of reminds me of like a train car or else a loaf of bread or something. You'll notice that the top part is actually just a semicircle, isn't it? So it's a cylinder cut in half. Okay, so that top part is just a cylinder. What we're going to do with that cylinder is that we're going to cut that baby right in half. Okay, so we need to take the volume of the cylinder, divide by 2, and then we need to take the volume of the rectangular base, and we'll just add those two together, and we'll get the volume of the whole doggone thing. Okay, so how do we do this? Well, let's go ahead and look at the volume of the rectangular base prism and then also the volume of the cylinder. Okay. And we know that this one here is base times height, right? We'll go ahead and do that one first. Is base times height is the base of this. And let's go ahead and make this whole front side here the base. So we got 20 times 30 for this base in front, and then the height of it, there it is, 50. In fact, this right here would be 50 also, wouldn't it? Okay, so this one's not so bad. We can keep on going with this, and we'll find that the volume of this one is actually 37,500 cubic centimeters. Interesting, isn't it? Now let's look at the cylinder. Remember that the volume of the base is actually pi r squared h. We still got to divide that thing by 2. Okay, so what does that look like? Okay, this is going to be 25 right here, isn't it? 25 centimeters right up there. So for the radius, we got to cut that in half, don't we? So it's going to be 12.5. We're going to square it. Times pi, because pi r squared, that's our base. Times the height, 50. And we still got to divide that thing by 2. Okay. Okay, so let's go ahead and calculate this thing. I've got the top all calculated. We got 24,531.25. I still have to divide that thing by 2 because, again, that's only half of a cylinder. And so that half a cylinder actually equals that. So we need to add these two up together. Let's do that. Okay, and when I added the two together, I got a grand total of 49,765.6 cubic centimeters. Such a big number, but you got to look at. I mean, these are big numbers too. Okay, 12.5 there and 30 there. Those are large numbers. And when you start multiplying things together like that, they do get large. Okay, so that's finding the volume. The surface area is a little bit more tricky than that. So let's go and look at an example that's like surface area. Number 3 in your homework. Okay, well, I'd like you to look at something here real quick. Okay, let's say that this is a composite of 2 rectangular base prisms. Now they've got 2 sides that are touching. So I'm going to go ahead and start that. Notice those 2 sides I've got the green Post-it notes on. They were touching. So where they are touching, we don't do the surface area of that area. So sometimes you can make that really difficult, or you can try and simplify it as much as possible. So let's look at this. What do I do next? I'm going to peel off that. So now I don't have to figure out the top and bottom of that cubic there. Oh, let me do it again. Okay, so there they are. That's where they touch. You can't use that surface area. So I put it on top of the box. Now, hey, the top and the bottom, we don't have to calculate. We can calculate this whole rectangular prism surface area, but why bother subtracting this amount from it and then subtracting this amount from this one? Instead, why don't we figure out the surface area of this minus the top and the bottom? So I'm going to do that when I do my example with this. Okay, so let me get this out of here. We'll do this. Okay, and my video is still going, so hold on. There we go. Okay, so here is something kind of looks like steps. Kind of a short step, I guess. Anyways, 9 centimeters, 9 centimeters, 9 centimeters. I wrote 9 centimeters up here so that that'd be a little bit more evident too. So let's go and take these two apart. Did that. So here is the base one. Okay, and here's the one sitting on top of it. So we have to figure out the surface area of both of these, but we don't really have to worry about this one on top. Now that one on top there is 27 square centimeters. This is 27 square centimeters. Why bother figuring that out when you just got to subtract it? Why not forget these two? Just don't even do them. Just do the outsides of this. And do you remember that I talked about how, yeah, you could figure out the surface area of a rectangular base prism by taking the front plus the back plus the side plus the side plus the top plus the bottom. Instead, I do it like this. Remember, I double up the front because the front and the back are identical. The front and, oh, which one is the front here? Here, this one, front and the back are identical. The top, well, we don't even have to worry about the top with this one. Let me get that scratched off of there. Okay, because the top and the bottom, we're not going to calculate that 27 right there. Okay, but the sides, here's a side and here's the other side. Those are identical. The 7 times the 9, those ones are identical. So let's see. I'm going to get this one out of here. Okay, and then now let's look at the bottom. Now, since that 27 that's right here, we're going to count that because we decided to subtract it off of this part. Okay, so here's this one. We'll do the whole one. Now remember I said that what do I always do? I always go and put my numbers on the 3 sides that you see. Okay, and so I'm going to do that. So the top of this one we know is 27, so we're not going to worry about that. But this is 7 times 9 in front right here. Okay, so that is 63. Okay, and let's see, okay, and then this side right here is 7 right here, and there's a 3 there, so there's going to be a 3 here, so 7 by 3, so that's going to be 21 square centimeters there. I wish I didn't put that 9 on there. But anyway, so then this one, the 3 sides we see right here, they are. Okay, this one's 7 times 9, which is 63 square centimeters. And let's see, this front side here, 18 would be times 7. So that'd be 126. Okay, and then the top would be 18 times, what would that be, 9? So it's 162 square centimeters. So let's go ahead and take this information and put them into the formulas, and we'll go ahead and solve it. Okay, so let's go ahead and do this top one here. So we've got the sides here, so that's 63 square centimeters. We don't have to worry about the top. And then the front side here, here we go. Put that in there. There we go. Okay, I'm experiencing difficulties. Okay, so we got that one set up. We'll calculate that in just a moment. Okay, front, top. Psst. That's a southern sound I think I just made there. and then 63. Okay. So I'll add those up and we'll see what they look like. So give me a moment. Why don't you go ahead and add them up at the same time? So I went and added these up in here, and now we'll go and multiply it. Okay, and then you get 702 square centimeters for this large one. And for the small one, I am going to get 168 for the small one. And once I add the two together, I get a grand total of 870 square centimeters. Okay, so I got 870 square centimeters. Now, a reminder about that again, when you're doing these, think about what surfaces are going to be touching. Okay, like if you were doing this surface area, this one here kind of looks like a desk, you would not be counting these two surfaces that are touching, and so I wouldn't even bother figuring out the top and the bottom of that. Okay, and so I think that you can see something here that looks familiar on some of these. I mean, this looks really familiar to a shed or a house again. This one looks familiar too. Now you got a pyramid on top instead of a triangular base prism. What is this? You know, it almost looks like a jewel. But I think it's two pyramids there that the bases are touching. So you don't even have to figure out the bases of those two pyramids. Isn't that cool? Oh, wait, I'm wrong. I just read this. That's my problem. These are volumes. Okay? You do need to calculate the volume of one pyramid and the volume of the other. They'll have the same exact base, so that's cool. Okay. It looks like a soda can between two boxes, doesn't it? So this one is surface area, so you won't have to calculate that circle on top, on the top and the bottom of this. But I mean, you also need to take one off of the piece here too. So I mean, you're going to have to subtract some area from this one. That's a good challenge for us. And I did one really similar to that, so you'll be just fine with that one. Well, that's it, and that's all I got. So I'll see you when I see you, or I'll see you online sometime soon, right? And you good day now, everybody.